So this is the main page from Airhacks Industry. It's just a joke, but if you go there, you will find all links about me. I like Java, and I spend 100% of my time in Java. This week is a bit crazy, so I'm the entire time in train with conferences, but this is unusual. Since pandemic, I'm working, the entire time from home and hacking Java code. So this is what I'm doing. So I'm not a speaker, actually. So this is why, it's a little bit chaotic, but you will see in a second. So there is a podcast there are already 260 episodes. Maybe the interesting JAX-RS, there was one about how Lambda works. There was a podcast with Kelsey Hightower, or a podcast with UML people who invented boundary control entity. So I have just fun. There are no ads, no agenda, chaos as always. Then Airhacks TV, if you have any questions left, first Monday of the month, you can submit question to GitHub Gist on Ask Me Online, and I will try to answer this. Why I'm doing this? Because I'm not answering any questions per email. So this is, otherwise I would be crazy. So this is this works. Any technical questions, right? And YouTube Shorts are also nice. Discord, some workshops, and now about the content. So what I would like first, if we start, this is the important distinction. So what is the difference between web scale projects and my projects? So web scale would be TikTok, and my project is more like a boring database with a few hundred people from internal company who are accessing the page, but they are behaving as they were TikTok. So everything has to be highly scalable, reactive, or whatever. But actually, there is no one who accesses the system. So the keynote is about the enterprise systems and not about TikTok. If TikTok, you should maybe behave a little bit different, or you're building Amazon, Alibaba Cloud, or whatever, right? So this is the deal. So what are web scale applications, or why it is not full screen? Wait a sec. My PowerPoint PDF viewer is broken. So in web scale means no vacations, 9 to 5, unpredictable loads. It means there can be spike at Christmas, who knows. Fast scaling, latency is important. So if something is slower than 10 milliseconds or 100 milliseconds, you lose, your some money. And I would say I was never hired in a project because the page was, 80 milliseconds slower than supposed to. So they have more problems than this, right? Usually. And multi-region deployments may be necessary. So what multi-region means is we have one cluster in Frankfurt and the other one, I don't know, in US and Australia. So maybe one of my projects will go that route, but all other projects are happy in Frankfurt or in Zurich, there's a zone or whatever, right? So right now I'm mostly working with AWS because of projects, but 2 years ago I've worked a lot with Azure. The only reason why I mentioned AWS right now is because I know the names better. But there's a table, if you search, there's one left side, the names from AWS, on the right side, the Azure name. So they are very similar services. So it's not like, something is only uniquely possible on the AWS. Enterprise applications. This is what I think suits better. This is what I'm doing. So most traffic, and this is actually in Germany, so 8 is wrong, 9 to 5, because at 8, there is no one here. It was closed here, actually. So, I mean, this is wrong. So I was 5 to 8, and I was unofficially, was here. So there are vacations. Spikes are possible, but unlikely. Maybe, after the lunch break, everyone hits the system at once. And mostly boring CRUD use cases. I would say, even this is still create, read, update, delete. You are still database, maybe 50 databases because the administrator went a little bit crazy with normalization. But usually it is not like And often private cloud means not everything has to be visible from the internet. And usually one region, and usually in my project it has to be in Europe. It is in Frankfurt on Ireland. This is what happens, and or in Zurich there is also your own. I think Zurich you have your own region right now. So what is cloud native and green IT? Just one slide. So what I want as motivation, this is what I also showed yesterday, this slide. What it means is Java is actually very good. So this really surprised me. There is a study, and Java is very energy efficient, and very means number 5 after ADA. So if you like to better than Java, learn ADA, this is the future. So not entirely true, but Rust is actually better, I have to admit. So Rust would be an improvement, Go not necessary, right? Go is not that good from energy efficiency. And Ruby and Python are 35 times worse than Java. It means This is very bad for the environment if you do Python or Node.js, right? So if you would like to, if you are I saw here bio market or whatever. So if you think about your environment, beautiful mountains, and global warming, stay away from Python and Node.js. So this is like the message of the day, right? And no kidding, this was fun, but performance is more important. What it means is the faster it is in serverless, the cheaper it gets. So this is what interests my managers. And I say, look, if we just do this, we will pay less, and money talks, cost-driven architectures. This was yesterday, the entire day, we talk about that. And so what the cool story is, if something is fast, it's also mostly energy efficient. And with Java, I would say, I'm pretty sure we are more productive than C, and I would even say than Rust, but it really depends how passionate you are, all right? No mission distractions. So if you are a bank, you should care about accounts and clients and customers. If you are, I don't know, insurance, you should sell insurances and not play, with your networks. This is the idea. So, and if you are a Markthalle, you should focus on good coffee and not Kubernetes, for instance, right? So instead of doing coffee and food, they can start their own private cloud with Kubernetes and do, I don't know, hot deployment or whatever. Not necessary. And in some projects, it really, if I'm in my clients, they spend significant amount of time playing with the infrastructure, and the justification is they are portable. But the justification we had in Java for 20 years. I don't know what they remember. There was a databases at the beginning, right? There was the DB2 and Oracle and Microsoft SQL. And we were busy decouple the databases. Because they say one day someone will come and switch the database. What happened actually is the databases outlive the applications. I think in 80% of all cases, the databases lived longer than the apps. So they burned billions of DAOs, DTOs, mappers, and dozers, and I don't know what, lost completely money-burning machine. And now the same happens abstractions in the cloud, right? So if we have portable code and we deploy in a cloud another cloud called Kubernetes, everything is going to be, better, because one day we can move out for this cloud to the other cloud, and yeah, you could, or you can say we write simple code and we move the code between clouds. I'm as fast, but not portable. I have to do something. Okay. By the way, you can ask me questions and say what you are saying is not true. So this is an interactive keynote, as I said, right? So I'm not for clouds. I actually don't like cloud a lot, but sometimes you have to go to the cloud. So now the question is, if you are on premise, you don't go to the cloud, what you could do to be better than in the cloud, right? So, I mean, if someone tells you you have to go to the cloud or you have to stay on premise, this cannot be true. There is not like 0 or 1, right? So this is, if you go to the cloud, you have disadvantages. If you stay on premise, you have disadvantages. So now first, if you stay on premise, what do you get out of that? What I will do, if you are on premise, what we get Java 21. Right now, it is LTS. My trick is to send my clients an email. I did it actually 2 days ago to my larger client and say, hey, Java 17 is no more secure, which is not that true, but Java 21 is the next release. Java LTS, you see LTS stands for long-term service, and if you do Java 21, everything is better, and they thought about this, and I will maybe become Java 21, but never say it is cool or whatever. Say more secure, stable, and cheaper, whatever, right? So then you get it. So virtual thread structured concurrency, what it means was the first one. If you're on premise, you can influence the hardware. So you can buy the largest machine available for pennies. So we had yesterday we did some calculations in the cloud. Raspberry Pi in the cloud costs you 500 euros a month. This is what we did. We proved the point, right? On premise, if you go to Digitech, or what's the name of the company here in the basement, and buy, for 3,000 euros, you get I don't know what, and quantum computing engine, right? So this is impossible, right? So you get 64 thread ripper, whatever. And you can run virtual threads. What are virtual threads? This is technology which will kill reactive programming. Already killed 80% of all reactive programming cases. What it means is there will be one talk about virtual threads, so you have to attend. So I had that from Kai, right? You see here? So today will be a nice talk, so you have to attend. So what it means is you get millions of threads, and these threads have, kilobyte or byte stack, so they don't cost you anything. They are completely free. So you don't have to play with AK, Mutiny, this await or whatever. You just write simple Java code and you are done. And structured concurrency, what structured concurrency is in preview, but will come soon. You can have multiple threads and like a barrier which waits for all these threads to complete, right? Project Laden. Project Laden is also will be more likely in on-premise because you have to have more control over the parameters. But what Laden is capturing what is lightning in the bottle. They are working on fast startup times in Java, so you can say, I would like to have more performance or faster startup time. Working right now on that. GraalVM and Mandrel I will show you after the session, so I will live natively compile you to show you how it works. What GraalVM is, you can reduce Java RAM by 90%. So if you have running Java applications, you can use Mandrel, which is upstream to GraalVM, or GraalVM to compile bytecode to native code, and you get one file, it's roughly 25, 30 megs. This is the JVM with the entire runtime in the application, starts in milliseconds, and consumes almost no RAM. Java JFR, Java Flight Recorder. Hardly to do in the cloud, but what you can do on premise, you can run your application in constant monitoring mode. It will constantly emit JFRs, records everything, we actually did it, and you can have Java mission control to see what happens in real time on the machine. So it generates a lot of amounts of data, but there's no problem. You are on premise, so you can just do it. In the cloud, harder to do, right? You have the pods or you have containers. You have to store it somewhere. On premise, way better, JFR. Crack is something good. I mean, technological perspective. It means coordinated restore at checkpoint. This is OpenJDK technology, and what it on Cryo is the same from IBM. So what Crack does, you can freeze the entire JVM, and it starts faster the next time. So this is harder to do in the cloud. Again, why? Because usually, if you go to serverless route, clouds are doing for you. And on-premise Kubernetes is great because you can create your own cloud. So I mean, just do it. And with Kubernetes, you can customize the pods to use all the technologies I mentioned right now. But if you're on-premise, if you don't do it, lost opportunity, right? So you're on-premise, you have the control, and you just use basic JVM, which is a pity. So you can use custom operators to start your Postgres, whatever. We actually did it. So we created custom operators to start a cluster of Postgres. There is a Zalando, I think, operator, and there is StreamZ for Kafka, so you can absolutely do this. And on-premise, open source rules. Prometheus, Kafka, Jaeger, just Postgres. Open source is the way to go. Why not, right? I mean, this is far more reasonable to use open source technologies to something commercial and hope that the company will survive. Okay, so now, what you can do on-premise as well, it's called data-oriented programming. I'll show you on a slide what data-oriented programming is. It looks like the structuring in JavaScript. You can do it with Java records right now. Hopefully, it will kill all the data mappers, DTOs, and whatever you have to still write. I mean, if you invoke get and setter with the same name, something is wrong, right? So this is also bad for the environment, I would say. Monolithic deployments. So we do it all the time. We actually built monolith for years. But it is, I can say it, I built monolith, 5 years ago, I would told you we create big microservices, but right now, I don't use microservice anymore. So actually nothing changed. I only vary the names depending on year, right? Next year, I will talk more about AI. So we will invoke a string method and get a string back, and now OpenAI is also integrated in, right? So no kidding, this is the AI integration. So now, monolith, what's pretty cool, for instance, just an example what you can do. If you use, for instance, Azul system, Zulu, they have OpenJDK with proprietary feature, which is pretty cool. So you have to pay for it, but just as idea, what you can do on premise. Code inventory. If you turn it on Azul systems and in local deployment, it will show you which code was used for migrations. Imagine, old project, you run it here, you test it, and it will say, okay, this 30% of the code is tested, it runs, and 70% was never touched, you don't have to migrate it. For instance, try to do it in the cloud, harder. You have to replace the JDK or whatever. So this is just ideas what you can do, and you have full stack advantage. For instance, right, if you have Quarkus with Vertex, and you know which Linux kernel you are using, you can use IOU ring This is a new way of interacting with the Linux kernel, which minimizes the system calls and significantly improves the I/O in performance and blocking. But you cannot do it easily in the cloud because you have less influence on the operating system. Okay? And monitoring, open telemetry, you can set it up. So what it happens with span, everything is monitored, and you don't have to pay for it. If you do it in the cloud, you have to pay a lot, manage Prometheus and so forth. So what I'm telling you right now, that on-premise is complete different strategy and infrastructure as in the cloud. Okay? So this is what I still saw. This is actually the code I reviewed recently. I just changed the names. There were hundreds of lines like that. And the architect was proud. He said they decoupled everything. And I look at this, this is a great job. But you know, if this is everywhere, is this? Now the question is, where is the decoupling? You know, if this is the rule, and there is never a change, I would say, okay, then you know, this is like, I don't know, it's bad, right? So, but so what happened is, I guess why Python and Node.js had actually the chance to be more popular is because the Node.js and Python developers saw this and said, not with us, right? So we'll never write such a code. And because this code was verified by the architects, but no one looked at Node.js and Python, and that's why the project was so popular, because this idea to write such a code only Java developers can get. Yeah, ask many Python developers whether they would write such a thing. They say, never. Node.js also not, and Java, of course, is enterprise, right? So this is one of my YouTube shorts, actually. And this is Java 21. This is everything on the slide, so it is runnable. Actually, tried it yesterday. So there is a dev, and dev has a runtime, which is age, so we are very young, right? And weight, very lightweight. So for instance, I saw in the workshop, usually all of us were around 20 and 65 kilograms. So this was what happened yesterday. And so if you have a nested record, you see this? Nested record. And now this is cool. So I'm passing here an object from here, and I have a dev, and now look at this. I can here access the variables. It's the same as JavaScript destructuring. This kills all the DTOs, mappers, or whatever you call them. It's no more necessary, right? You got the point? So what I'm doing here, if this is type developer, then create, extract, invoke here the getter, and give me the value of name, age, and weight, and I can use it here. It changes everything, Java 21. You can do it right now on premise. Email first, Java 7 is insecure, then you can do this tomorrow. So, oh, exactly, you see. This was why yesterday, what I did, this was a nice border. Okay, now, in the clouds. In the cloud, forget what I told you right now, it's completely different. I would say the path of least pain. If you're in the cloud, and I hear already we have DevOps or whatever, means, okay, my team or I will have to do everything by ourselves. If I know it already, it means I will try to skip anything which has to do with networking, backups, patches, maintaining, and any compliance, because this will kill us. Okay, question to you. Who already did something with the cloud? So, I mean, provisioned a resource of you. Hands up? Okay. Who provisioned a VPC or VNet? Who liked the experience? No one. This is, everyone says, okay, clouds are great, and then you do the first 2 hours, and they say, never again. So, and the VNet is like Java installation on the machine. This is not even less. The VNet is like, I have to go to MediaMarkt and buy Windows 95, right? Then I have my operating system, and then I can install something. So what it means, if you would like to have a Postgres database, we did in the workshop yesterday, already we talked about that, what you will have to do, you will have to create a VPC with 6 subnets, 3 net gateways, 1 internet gateway, deploy the database, create secret keys, decide what is the backup maintenance window, and then test whether the backup is running. And then if it's done, you spend 2 days, if you're good, week usually, and you have one single relational database, which will cost you at least, we did the calculation yesterday, 350 euros a month. Size, Raspberry Pi. Okay? So what it means is, if I have the chance, I don't do it. It's like, okay, this is I'm not crazy, right? So means either we have ugly code or we have to do this, right? So for me, I would say, okay, I write Java code which is not that beautiful, but I don't have to do this, what I told you right now. Because we have to do it once. If microservices are still a thing, and someone gets the idea to have 20 microservices, you have to do it 20 times. And then and actually, if you would like to do it securely, you have to do it 20 times in 20 accounts. And have a pipeline which has the permissions to access 20 accounts at the same time. Or actually 20 pipelines from 20 accounts, right? So you see it is going a little bit crazy. So what is in the cloud? First, costs. I cannot go to a project and say, hey, every microservice gets a database for 1K for CRUD. The client say, what are you doing here, right? I mean, I thought it's an improvement. So I think the reasonable thing to do is serverless first. What is the serverless? So long story short, pay as you go. You are paying per invocation, and there is no setup. That's basically it. You get a table, and you use the table, but you don't care about the database. Therefore, what I think is, actually we are doing this, there is new buzzword called no-ops. And what no-ops means is, if you commit something to GitHub, for instance, the entire infrastructure is provisioned for you, so there's nothing to do. And nothing can die. You know S3 bucket? S3 bucket, this is, yeah. The question is how to operate an S3 bucket. You cannot operate it, right? So S3 is this first serverless persistence. It is simple, has simple storage service. It should be serverless storage service. So it's absolutely serverless. There are no operations, no maintenance, no administration for buckets. They are just there. And the idea of buckets, I apply everywhere. Buckets, DynamoDB, the same story. Lambda, the same story. SQS, SNS, Kinesis, the same story. It means there are no operations. You cannot operate a DynamoDB. Impossible. You can just watch, is it too expensive or not, but it cannot die, right? You cannot restart it, and you cannot increase memory. Agreed? That's the idea. So with Java, also what happened yesterday, so we created or proved the point that you can actually create a modules, jars, Java jars, which create the infrastructure automatically, and you can share this in the entire team. And this is called CDK, and I would like to show you afterwards. So the code, this was the deal. So next generation runtimes, actually two I'm aware of, Quarkus and Micronaut. Why they are next generation? Simple trick, what they are doing, they are optimizing and deploying the application at build time, not at runtime. This is the entire trick. Therefore, they eliminate reflection. Tree shaking happens behind the scenes, so only the code is active, which is actually used. Why they know it? Because of dependency injection. And this is why they are so small and start that fast. And this is why I'm only using actually Quarkus. Micronaut not yet, because the source code is not microprofile compatible, and most of my projects have something to do with microprofile of my clients. But Quarkus is, the Micronaut is getting there. They are working now on microprofile, so we'll have two interesting runtimes which are interchangeable. Helidon, also very fast from Oracle, but not as advanced as Quarkus and Micronaut. So what it means is Quarkus starts in 600, 300 milliseconds with the GraalVM 10 milliseconds and less. You will see it after the session. So, and you can use monolithic AWS Lambda or Azure functions to deploy Quarkus and Micronaut on that. So actually, what we did yesterday, then half a day, not the entire day, we created, or we talk about it, I showed also some code. What you have to believe me, just, it's very possible to pick your monolithic microservice, 500 Java classes, package it as a Lambda, and it works without any infrastructure. This is the entire trick. So what you can do in the cloud, or what you should start with, is to say, okay, Java optimizes a lot, so there's not a problem to have, hundreds of classes. So it is absolutely viable to have a monolith, a big one, deploy it as Lambda, and run it securely. Why securely? Because there is nothing, we can do actually wrong. So there is no operating system. Java is patched by AWS's Corretto or Microsoft OpenJDK. So Oracle also has an JDK, right? So the idea is all the patches and boring stuff happens in the cloud. So, and of course, There should be no VPCs, no subnets, no IPs, no containers. Actually, containers, why I need a container, right, to run my Java code. So the Amazon or Azure should just run my Java, whether they run it on containers or not, I don't care, if you think about this. Okay? If I like to run containers, just do it on premise. Why in the cloud? In the cloud should be an improvement, step forward. And no connections to manage. So actually, the next idea of cloud native is everything accesses the cloud via HTTP. What I forgot to mention yesterday, if you access by HTTP, all the audits called CloudTrail also happens behind the scenes. You will see who did what when, because everything goes through the same API. So runtime. So we had something like application servers with multiple deployments. This yellow box is deployment. Then we did microprofile with multiple. This happened, and the only difference to now, we replace the container with Lambda or Azure function. No difference, right? So, and then we are able to run the same stuff as AWS Lambda, Java SE bare metal, and container. So this is what Micronaut and Quarkus are doing out of the box. Also like to show you after the show here with source code, but without container. If you like container, but container is obvious. So yeah, we start on bare metal and as Lambda if you like. So now you are all the Java developers. What is the difference now on-premise to the cloud? On-premise, you have a big app server or something similar to app server. By the way, the app server term is now used a lot by Python and Node.js, which is surprising. So in Java, it was like, say, okay, this app server we are not using anymore. They use the term middleware, and now I hear more and more app servers. So app servers is back. So we can talk about them freely right now. So you only have to wait 10 years, as always, and then you come to the next hype cycle. So now we have app servers again, and the app servers use threads. Project Loom, virtual threads. Great thing, right? This is what you can do, because then you can have millions of requests, and they will cost you nothing. So, and this is Lambda, completely different. The difference is one request is handled by one process, not thread. 1,000 Lambdas, 1,000 processes in parallel, 1,000 CPUs. This is the main difference. So you cannot easily cache in static map something, right? Because you get 1,000 caches, not one. So cloud native serverless, okay, the servers, interesting cost-driven architectures. Everything at cost, and I spent, no kidding, most of my time at the beginning of the project in calculators, price calculators, because there are in Amazon, I think, 300 services, and you can run containers in 20 different services. And what you pick has only actually impact on the price, nothing else. So only price counts. If you go to the cloud and budget doesn't play a role, I think the architecture don't make any sense. You can pick whatever we can stop talking. It doesn't matter, right? So now a term, marginal costs. I got this from a manager, and this explained me why it is so important for management, the serverless, because the invoice looks different. In serverless, you pay per request. So you will see on the invoice, this module, you spend, I don't know, 200 gigabyte seconds, what means, it was 1 second was 200 times invoked, and it consumes 1 gig of RAM. So what it sees on the invoice, you will see how often the resources are used. And then marginal cost, what the managers are doing with Excel usually, they say, okay, we are selling or doing whatever useful here in this service, and one call cost us 30 cents, and we have the margin of, I don't know, 50 cents, you can do whatever you like. So what it means is whether it is expensive or not depends on the margin. The problem, if you go Kubernetes route or virtual machines or whatever, the next question we get in the cloud is, what runs inside the cluster? Show me what consumes all the resources. And then, funny enough, you have to install, for instance, kube costs into the Kubernetes to find out what happens inside, which is, I would say, craziness on earth, right? So host was better than this, because the host guys could exactly say which query was the most expensive. Okay, marginal costs. So what about the costs? I just did some screenshots. So 1 Lambda, 1 gig of RAM, 2 gigs of RAM. This is more than 1 CPU. What you get, you cannot buy CPU. You have to buy CPU with RAM. You see, 2 gigs is a lot, but I do it on purpose to have faster startup times. It is invokes 2 times per second the entire month, and this will cost you 15 euros. So if you go to a project and show this, and 2 transactions per second the entire month, day and night, for enterprise project is a lot. For TikTok is nothing. For enterprise projects is a lot, right? So I would say usually the peak 50 transactions per second, regardless how big the company is. You don't get for an enterprise project more than that usually. Okay? You get? No. So the next step, I forgot to show you yesterday. This is Fargate. You can say, okay, I'm serverless, but not that serverless. So this is 1 task per month, the entire month, 8 gigs of RAM, 1 CPU. Now I can utilize it whatever you like, and you will pay 50 euros a month. And you can say, okay, what about Kubernetes? Kubernetes would mean nothing. You start an empty control plane without any worker, and you pay 100 euro a month for nothing. You didn't start, just to have Kubernetes in the console, the icon. You pay for the icon 75 to 100 euros. So what it means is we can do Kubernetes. There has to be the question why, or make it at least transparent. The interesting part, if I make it transparent, I never do Kubernetes. So since pandemic, I was in no Kubernetes project anymore, because if you show this to management, it absolutely dies. Or we get, okay, we have to evaluate the alternatives. We didn't know about that. So they are not, people are assuming in the cloud only Kubernetes runs, but there are far more possibilities to run a Java workload than Kubernetes. And by the way, mostly portable. So mostly portable, what means is, the portability, I always hear about portability. The question is, which portability do you actually mean? Our code is absolutely portable. So the Lambda code can run on bare metal, on Docker, whatever, doesn't matter. So infrastructure portability, more interesting. So if you consider this, nothing is portable, because Azure has complete different permissions model than AWS. Azure has complete different networking model than AWS. Azure has a blob storage and AWS has S3. So, and no one talks about data portability. Try to migrate 20 terabytes of data between Azure and AWS. You will pay egress costs. And this is the problem. And I would say the Java code and containers were never a problem. You can pick a container runs elsewhere. This is absolute no problem. But I don't know why everyone focuses on the Kubernetes and this portability. Maybe this is the easiest one. So it's like, let's kill everything with that. But this reminds me really with DTOs, DAOs, and data mappers, and everyone hoped that one day DB2 is going to be replaced by Oracle, that we will prove that the decoupling was actually necessary, right? So what cloud native means is that the control plane and data plane are accessible via HTTP. You may ask why, and the answer is, if this is true, we can automate everything. Example, if you will provision Kafka in the cloud, it will take 45 minutes. You have to decide how many brokers you would like to have, zookeepers, and you have your Kafka cluster, which is empty, no users, no certificates, and then the stage 2 begins, where you, with your proprietary QCAT Kafka means, have to set up, the internal state of the cluster, right? If you use alternative to Kafka, which is highly proprietary, called Kinesis on AWS, you just say, via the control plane, I would like to have new topic. Half second later, you have the topic. There's nothing else to provision. Why it's possible? Because it's the same protocol. It is fully integrated. So what I'm talking about is, on-premise, all the open source tools make absolute sense. In the cloud, the open source things are not as well integrated into the cloud as the proprietary resources. And this is huge difference for automation, no ops. So what I try to do to automate everything, so I would like to have the permissions to the table, also what I show you after the show. So I will actually show you this point, because with DynamoDB, how it looks like, how the permissions look like in Java code. Okay, and of course, no IPs, VPCs, and operating systems. So, fat monolithic function. So what it means is, new pattern, let's say this big, huge monolithic function. Why? AWS, they are talking about single-purpose functions, and they are crazy to have no small functions. And if you have create, read, update, delete, the best practice would be to have 4 or 5 functions for each HTTP method, 1 function. So like, you call me crazy. I mean, now imagine you would have to deploy 500 functions. Why? And the answer is, yeah, the scale is better, it's more secure. So okay, this I don't believe it, right? So why they propagate the single-purpose function? Because most of the examples are not in Java. They have Python and Node.js. And with Python and Node.js, it is significantly harder to create larger apps. Also, larger apps boot slower. If you have Quarkus, because it optimizes everything up front, it doesn't matter whether I deploy one class or 500. So why I should deploy 500 functions? I still didn't find the answer. So I had lots of questions to architect and never. So then I wrote an article actually, an AWS blog about that. But this was the title, but they had to they changed it to something Java microservices on Corretto because they didn't like fat monolithic. But this is it's maybe in the resources, and there was no backfire. So this is actually I described as one function with lots of stuff, and there was no no problems actually. And there is the direct opposite of that what I propagated. So this fat monolithic function looks like Whitefly. This is JAX-RS with endpoints and lots of endpoints. My current project, we have hundreds of endpoints. It's not a problem. It's also a misconception that Lambda has to be one function, or Azure function has to be one function. It can be hundreds. It doesn't matter. What usually happens, you register your runtime as a Lambda, and it dispatches to all your Java methods. So this is, yeah. What I wanted to say with Java, Maven or Gradle, we have actually unique powers which can really use in the cloud, and in other languages it's a lot harder. You only have to compare, our Java examples with Python Node.js examples, what they are doing and what we are doing. So, what is this asynchronous event-driven function? This is a Java POJO, which listens not to HTTP, rather than to Kafka. It listens to Kinesis, SNS, SQS, DynamoDB, to an event in the cloud. To give an example, typical enterprise use case, Excel upload, right? So I would say always the same circles, right? So there's a Quarkus with REST easy, multi-part, has to be integrated, but it's not part of the JAX-RS. Then they upload it in temporary folder. Then I say, okay, what happens if we are then in next cluster node? So the temporary folder is read again and stored in the database, right? And so this upload waits to be invoked, and I don't believe there's not that many uploads per day, right? It's not like you get 100 uploads per second or something. I mean, this is not like the employees are that eager to upload Excels. So this is like, it happens maybe once a day. What is the cloud-native serverless alternative? You upload the Excel directly to S3. The most secure and fastest upload you can get. So, and even most compliant update. It is versioned and it cannot be changed. It is from the legal perspective the most secure one. Or to Azure Blob Storage. It's the same, right? So to S3. So you upload it to S3. S3 emits an event, and this event is distributed via Event Bridge. Exactly one line of code to activate that. So, and this Event Bridge has an S3 event. This is a piece of JSON. You register a Java POJO, and this Java POJO receives this JSON, and now you know that someone uploaded a file. You can immediately access the file, and you are done. So 1 million such uploads are completely free. It means if you change this, right, this piece, you can already save hundreds of euros per month, and the entire, I like really microprofile and everything, but the entire microprofile with JAX-RS and Quarkus, you can completely remove and replace with one S3 bucket and one POJO, decrease the costs, increase the security, and everyone is happy. This is just one example. Agreed? There are no questions, for the keynote is strange, you know.
What's the 100 euros per month? Where do you save it?
The 100 euros a month?
So you say you can save hundreds of euros?
Yeah, because in a larger company, we created a proof of concept, and this was a Postgres database with a small Quarkus, and it costed it cost 500 euros a month. Service in Postgres, and I do lots of proof of concept with ECS Fargate, and I have Fargate running because I do this for my clients. An empty Fargate with one node, small one, will cost you roughly 200 euro a month. So, and this is not. I have just one node. You will need two nodes, so I will assume 2 small Quarkus instances with 4 CPUs and 1 load balancer and VPC will cost you 200 euros. So, and in enterprise development, it will be a little bit more, so I'm pretty sure there will be hundreds of euros. Agreed? And if this would be Kubernetes, it would be 100 euro more because you need the control plane. So what's the absolute killer feature, what I'm talking about is, what this means is, if you invoke services, right, you have to hit a threshold like millions invocations and then you pay something. What it means is we all get production environment for test purposes for free. Because every developer can set up their own production environment and use it, and it will cost you anything, which is hardly possible with Kubernetes. Because you will have to pay at least 100 euro with control plane or play with namespaces to achieve the same, which is not exactly production. But in serverless, you get exactly production. Yeah.
You mentioned that 1 million was they could be free.
Yeah.
So owner of the cloud sets this value.
Yeah.
Could happen if in the future so many people will try to do this approach and then they will
Yeah.
make limit lower and
Yeah.
possibly could kill your business because of that.
Yeah. What he said is what happens if they increase the prices, right? Yeah. So first, it never happened in the history. So the prices are constantly decreased because there is huge competition still. But I'm waiting until it happens. But in larger companies, it's not like the companies are operating the clouds by themselves internally. They hire external companies, and they barely decrease their prices. So my observation is that this internal data center gets all the time more and more expensive, but the cloud's not. You know, so I would say you have the same problem internally as an external data center, and the million requests free, it is actually wrong what I said because it's free tier. We eliminate that. But even the million, what you saw here, this was like 15 euros. No one cares about that, right? So there's the competition, but the same happens for Kubernetes. Kubernetes was, I think, free on Google, and they introduced the price. So this is what I'm saying. With that, you have less problem. The alternative is absolutely viable alternative. You forget serverless, you go ECS without Fargate, and buy the hardware 3 years in advance, and get 70% discount. But this is what management don't like to have, because they are talking about OPEX versus CAPEX. If they buy something 3 years in advance, they are no more as agile as they want it to be. You have just to decide what you want to have. And there's not. I was for on-premise before. Now comes the cloud, right? So if you go to the cloud, use the cloud, and not try to decouple from the cloud. This is the strange thing. So if you go, just pick, whatever like. And this was using Amazon Corretto for lean, fast, and efficient AWS. They changed this. AWS changed the article, but the first title was Fat Monolithic Lambdas, and they say we cannot publish that. So okay, then change it whatever you like. I don't care. So this is all the references, and I'm happy because now I can code. If you would like to have some stickers, I have it somewhere. So thank you for the questions in the keynote. It was fun. So it was a recap of yesterday. I hope I didn't repeat myself too much. And now one slide, and I will show you whatever I showed you right now in source code. Thank you.